Whether we're a salesperson trying to sell, a CEO trying to convince, or a teacher trying to teach, the fundamental purpose of their action remains the same. You see, we want to communicate a message that engages our audience. Communicate a message in such a way that the message sticks in our audience's brains. And persuade them through our message such that it prompts our audience to act. In other words, we want them to remember the information that we're presenting and use it later. Now, to achieve this, presenters and their presentations must be engaging for the audience to pay attention, allowing the information to be encoded in their brains. The presentation must be memorable enough for our audience to transfer this information from their working memory to their long-term memory so that they don't forget as soon as your presentation ends. The presentation should be persuasive enough for our audience to take note and for us to convince them to act. In this presentation, my focus is going to be on the use of ICT tools that we use for our presentations, such as PowerPoint, Prezi, or Powtoon, that teachers often use to present information within classroom settings, or even to, for example, hold year-level assemblies. We'll try and find out what scientific research suggests about the ways to best tap into our students' brains through our presentation, such that we can get maximum engagement, maximum retention of information when we're presenting in front of them. The following 3 principles are worth considering when it comes to creating engaging presentations that our students will pay attention to. After all, for information to enter our students' brains and make its way to their working memory, they must first and foremost pay attention. Principle number 1, storytelling can be powerful. Humans have always used stories to teach children about the world and how to live in it. Turns out, storytelling can be equally powerful when it comes to delivering new content to students in our classroom. Stories allow students to replicate experience, leading to higher levels of engagement, emotion, and motivation. In fact, students across multiple age levels have shown improved learning and retention across multiple subjects when key concepts are embedded within stories. Now, this is backed by neuroscientific evidence as well. Here's a brain that is listening to a series of isolated facts. Here's a brain that is listening to the same facts entwined into a narrative. This suggests that more neural regions are activated when facts are weaved into a narrative as opposed to when they're presented in isolation. Principle number 2, starting strong is critical. The amygdala in our brain is responsible for regulation of emotions and encoding of memories related to strong emotions. When our students are forming their first impression of the teacher or the lesson, the amygdala demonstrates a strong activation. Now, once that first impression is formed, the amygdala activity decreases and stays low for the rest of that lesson or that presentation. It is therefore essential to start strong. Why? Because scientific research suggests that we are wired to form early opinions and then seeking more information in ways to support our first opinion. Principle 3, Spatial predictability will guide attention. I will now present two images of brain scans. In these images, blue color represents weak activation and red color represents strong activation. One image relates to the brain of a person who is viewing images at random, unpredictable locations on different slides. The other image relates to a person who is viewing images at predictable locations on different slides. Can you identify which one is which? You see, the ability to predict where an image, word, or object will be located on a screen during a presentation decreases the quantity of neural networks required for its identification and processing. Spatial predictability, therefore, provides attentional cues to our students, which in turn has the potential to improve comprehension and memorization of information. So when it comes to creating PowerPoints or Prezis or Powtoon presentations for classrooms, it is worth investing time and effort in ensuring that all the slides are formatted correctly and consistently, with images, text, and headings appearing in the same location on each slide. The science behind being memorable. The primary role of the teacher when presenting information or content to students is for this information to make its way to the student's working memory in their prefrontal cortex, and then make its way to their long-term memory networks. So what does scientific evidence tell us about strategies that will make our presentations more memorable for our students? Principle 1. Multitasking impairs both memory and learning. The evidence is quite clear. Individuals can only explicitly focus on one task at a time. So when and if our students are multitasking during a lesson, they're not multitasking. They're simply switching back and forth between the multiple tasks instead of attending to these tasks simultaneously. This is called switch tasking. And what do we know about switch tasking? Switch tasking results in poor memory and future performance in all of those tasks being attended when a student is multitasking. Now, why is that? It's because multitasking activates shallow, secondary, and less reliable memory networks in our brain, which results in impaired learning and memory. Principle 2. Spoken words and written words don't mix. Reading information and listening the same information at the same time uses similar neural structures in the brain. So if you try to do both of these at the same time, the same part of the brain is trying to attend both tasks. This is similar to multitasking. And we've just learned why our brain isn't an efficient multitasker when it comes to dealing with information. Visual images and spoken words mix well. In contrast, seeing and listening to information at the same time uses different neural structures in the brain, activating different areas of our brain at the same time results in more meaningful activity in the brain, thereby allowing students to understand and memorize better. Why do we teach something to our students? Just so they can recall it on the day of the exam? I don't think so. As teachers, we want our students to believe in that information. We want our students to remember it, hopefully, for the rest of their lives. We also want our students to use this information in the future, if and when required. Whilst all the strategies that we've spoken about help create persuasive presentations, the use of visual cues and storytelling can be really effective. Between 80 to 90% of information that our brain processes tends to be visual in nature. About 2/3 of our brain's electrical activity is devoted to vision when we're awake. You see, our brain is hardwired to consume visual information and has extensive storage capacity when it comes to storing visual information. And it's not just that our brain is dedicated to process visual information, our decision-making capacity is also strongly influenced by visual images. The same goes for our biological preference for storytelling. According to research studies, personal stories tend to make up approximately 2/3 of our daily conversations. Our students' brains are designed to respond to stories. A scientific fact worth taking note of, worth taking advantage of as teachers. As teachers, knowing how our students' brains learn and taking advantage of this information will allow us to deliver engaging, memorable, and persuasive presentations that will let our students engage and encode the information, transfer it from their working memory to their long-term memory, store it in their long-term memory, and retrieve the information in the future if and when they need it. My name is Shardul Kanaria, and I hope that I've engaged and persuaded you with my presentation, The Science of Presenting.